Dear students, before proceeding towards analysis of electrical circuits by using phasors, we must understand Phasor algebra, how calculations are done with various kind of phasors. Here we can write for mathematical calculations, phasors can be treated like complex numbers, because we know complex numbers can also be represented as vectors on organ plane, like say we are given with a complex number or a phasor as z phasor is equals to z0 angle alpha. Then on organ plane it can also be given like this. It is at an angle alpha and the magnitude is z0. The argument we consider as alpha. Now for different cases, if we define like addition of two phasors. Addition of two phasors can be directly done either by converting a phasor into real imaginary form, or directly by graphical analysis we can do. Say if we are given that z phasor is z1 angle alpha 1 plus z2 angle alpha 2, then in this situation, for these two phasors, the final form which can be written as z0 angle theta, this can be obtained by adding the two phasors graphically, like say this phasor is z1 which is at an angle alpha 1, and there is a phasor which is z2 which is at an angle alpha 2. Now by using parallelogram law of vector addition, we can complete the parallelogram, and graphically we can find out the value of the z0 and the value of this angle theta. By using the formulas of parallelogram law of vector addition, also theta and z0 can be calculated. Another way out is by transforming these vectors into real imaginary form using the symbol of iota, and we can split, and finally we can convert it into the magnitude argument form. So that is another way without using graphics we can calculate. If we talk about product of two phasors, this is the one which we are going to use maximum. This is exactly like normal complex numbers. Say if we are given that a z0 phasor, which is z1 phasor multiplied by z2 phasor, and if z1 and z2 are given as z1 angle alpha 1 and z2 is given as z2 angle alpha 2, then this can be simply multiplied as you have studied in complex numbers that magnitudes are directly multiplied. So this will be z1 z2, and when two complex numbers are multiplied, their arguments are added. So the argument of the resultant vector of product will be given as alpha 1 plus alpha 2. Similarly, on these lines we can find out how we divide the two divide phasors in different calculations. So here division of two phasors can also be given directly, like say we are given as z0 phasor, which is z1 phasor by z2 phasor, and if we substitute like z1 angle alpha 1 by z2 angle alpha 2, then just like complex number here, the magnitudes are directly divided and the resulting magnitude will be z1 by z2 and arguments are subtracted, so it is written as alpha 1 minus alpha 2. So these two forms of product and division are going to be used maximum in our cases of analyzing alternating current circuits, and addition also in some complex cases is going to be used. In general, for basic fundamental level of alternating current circuit is not being used. Mainly you need to use multiplication and division, and let's continue with the next sections where you will be able to apply these results.